Welcome to Dynamic Host Configuration Protocol for IP version 4, otherwise known as DHCP. My name is Mel Haukershoven, and in this video I will explain what is DHCP and how it works in the computing environment. We will discuss what DHCP actually does, how the DHCP allocation process works, what it means to have scopes, and when and why IP address reservations and exceptions are used. This video assumes you already have an understanding of the different IP class ranges, how routers connect networks together, MAC addresses, and how to manually configure an IP address on a network device. If you feel you don't fully understand these concepts, you may find it useful to revise these concepts before watching this video. A DHCP server on a network provides a computer automatically with an IP address so that it can connect to the network. The purpose of this is to avoid network administrators having to manually configure each PC and therefore avoiding having to manually maintain a spreadsheet of IP addresses. A major advantage of having a DHCP server manage IP addresses is that not all PCs are online at the same time. Therefore, the DHCP server can reassign IP addresses to other computers while a PC has gone offline. This allows a pool of IP addresses to be shared amongst a large number of PCs. This allows you to configure and update hundreds or even thousands of PCs automatically, with not just the IP address settings, but also with its gateway and DNS settings. If any of these settings ever change, it's a simple matter of just updating the DHCP server without having to attend to each PC. So let's take a look at the actual process for how a DHCP server allocates an IP address. When you first turn a PC on, a PC that is configured to automatically receive an IP address will send out a broadcast discover packet. This broadcast will be received by all PCs on the network, but only a DHCP server will respond. Since this computer does not yet have an IP address, the DHCP server must also reply with the broadcast. In this reply, the DHCP server will offer the client an IP address. The client computer will perform a quick check to verify the IP address is not already in use and will then respond with either a request or a decline. If it sends a request, the client computer specifically requests this IP address and requests any further configuration settings as well. In the last stage, the DHCP server will send a confirmation that the IP address has been assigned and will send the further configuration settings. If any one of these steps fail, the client will not receive the IP address and will need to resend the request. An easy way to remember this process is to use the acronym DORA: Discover, Offer, Request, Acknowledge. So the process looks like this. I like to compare the DHCP process with making a doctor's appointment. In the discover phase, you ring the doctor's receptionist and ask if there are any appointments available. The receptionist looks up the calendar and replies with an offer. I've got an appointment available at 10 a.m. Does that suit you? You check your calendar to see if you're free and respond with, yes, could I please have an appointment at 10 a.m. The receptionist then confirms the appointment time has been registered and you have both secured this appointment. If at any stage your phone dropped out, you would have to ring back and try and make another appointment time. The DHCP protocol defines a few extra commands which I won't go into detail here, but just be aware that they exist. NAC, decline, release and inform are all used for communication between a computer and the DHCP server. There are certain situations where DHCP could fail and the computer may not receive an IP address automatically. One example is if the DHCP server goes down, or if the router is not forwarding DHCP broadcasts. Microsoft has built in a fail-safe into Windows so that a computer will still receive an IP address and connect to a network. This IP address is a special address, automatic private IP addressing, or otherwise known as an APIPA address. This is a Class B private IP address to establish basic network connectivity and to allow basic Windows services to run. A DHCP scope defines the range of IP addresses that will be allocated to computers on a network. It is possible to have many scopes to service more than one subnet. However, each scope must define a consecutive range of IP addresses. Therefore, all the IP addresses for a scope will be on the same subnet. However, the scope does not need to utilize the entire subnet range. This allows for static IP addresses to be configured outside of the DHCP scope. For example, in this case, for a DHCP allocation pool from 192.168.1.100 through to 192.168.1.200, then you can statically assign IP addresses outside of this range, such as 192.168.1.10. Since broadcasts do not go across routers, then how can we have a DHCP server responding to requests from several networks? To do this, routers are configured with an IP helper address which forwards the DHCP broadcast onto the DHCP servers. In this diagram, the router for subnet B is configured to pass on any DHCP broadcast to the DHCP server on subnet A. Sometimes we have a scenario where a device on your network requires auto configuration, but also requires the same IP address each time. A DHCP reservation is a specific IP address that is tied to a device through its MAC address. Using a reservation is almost like having a statically assigned IP address. However, if the DHCP server went down, then this device will no longer receive an IP address automatically. This is an important distinction and must be considered when designing your network. During your network design, you may have to decide between using a static IP address, which will always work, or using a DHCP reservation for devices that require an IP address that stays the same. For some devices, such as a domain controller or other servers, you may decide that it's critical that the server be configured with an IP address in the event that the DHCP server goes down. For example, computers that boot up while the DHCP server is down will not be able to connect to the network. However, users already on the network or PCs with a static address will be able to continue to access their files on the file server and authenticate against the domain controller. So just remember that if you choose to use a static IP address, you have to make sure the IP address is outside of the DHCP scope. Otherwise, you may need to make a DHCP exception for this IP address. If this is not configured correctly, this can cause IP address conflicts on the network. For existing networks, they often expand, change, migrate, or two companies may merge together. It can often be difficult to migrate existing networks to new network designs, and so sometimes we end up with a server, for example, that has a static IP address that cannot be changed. In these cases, to accommodate this server in a new network design, we can choose to create an exception for its IP address on the DHCP server. It is always best practice, however, to avoid using exceptions wherever possible. In an ideal world, you would always create your scopes to avoid static IP ranges, but the option is available for those situations where it's completely unavoidable. This means that the DHCP server will never allocate the IP address from an exclusion range, and the server can be safely configured statically with these IP addresses. You should now have a basic understanding of how DHCP automates IP address configuration, how DHCP allocates IP addresses to clients via the DORA process, and when you would use static IP addresses, DHCP reservations, and DHCP exceptions on a network. This concludes the video on DHCP for IP version 4. Thanks for watching.